Is it visible now?
Yes. Yes. It is visible.
Okay.
Screen mode.
Screen.
Full screen.
Cam in screen mode or not?
Now it is not visible.
Not visible.
Dr. Sunil, unmute yourself.
What is the problem? I don't know.
Unshare first and then share.
Yes, entire screen or window I have to share, no?
Yes.
This part is coming, but when I'm going to this slideshow presentation, then it is disappearing.
No, it was first shared. Yes, now it is coming. Okay, you can present from this.
This slide, if it is working, then I can go through this.
Okay, okay, you go.
Okay, so
you just check whether it is moving or not. Slide is moving or not. Just you can check.
Slide is moving.
Okay, then fine.
Slide showing हो रहा है क्या sir?
Okay. So, good afternoon to everybody, and I have also heard the previous lecture. It was really eye-opener for us that at what stage we are, and they are 20 years forward to us. We are, or we can say 20 years we are behind to them. And of course, we are also developing this drone technology, other technology, but still there is lot of gap, and we hope we will fulfill this gap very soon. My topic is entirely the contrast of that, where you were listening about the AI and other things, related things, robotics and other things. Here it is the most neglected thing, that is waste. So I am starting with this waste, and I'll try to give you a idea that how this waste can be changed to best, or waste can be changed to best. So this is my idea, and I'll try with my few database. My next slide says that we need a complete rethink of waste. To analyze it, waste is indeed waste. So our thinking should be changed, whether it is waste or it is not a waste. We can think that waste to become wealth, refuse to become resource, and trash to become cash. So in this context, you can see either you convert to wealth, or you convert as a resource, or convert as a cash. The choice is with you. The major area, because whatever I am going to explain, that is not directly one by one related, because each and every aspect is related to entrepreneurial aspects. But the major area of this waste management is waste collection. Here we can develop some entrepreneurs, we can develop some entrepreneurship, because collection is a very tedious process, and it needs lot of techniques, funds, resources, everything, and you can generate a lot of funds from this also. Then transportation of waste, that is also a very important area. Then very much important area is reuse and recycling. Here there may be different type of waste there, and we can reuse and recycle them. That is also a very income generating activity. Upcycling and power generation. So I'll touch all these aspects in my next slides. So my discussion will be on urban waste, what type, what are the generation facts, how to classify, segregate and dispose them, what are the rural waste generation sources and their facts, what are the alternate use and disposal, and what are the composting technologies, and how we are managing it at IRI composting model. So I'll give you glimpses of all these topics. So first, my first topic is urban waste. So if you see this database, then this whatever municipal solid waste is generated, you can see 1.33 lakh metric ton per day generation is there. And in India, we are collecting 0.91 lakh metric ton per day. That is only 68% of the total waste generated. And 0.42 lakh metric ton, that is 32% is littered only. And the treated is only 19%. And remaining about 49% is going to landfills. Just we are making heap of garbage outside each and every city or town. So why this way? More than 80% landfills where we are putting this, they are going to be full. And according to an estimate, about 1,240 hectares of land space every year we need to dump such type waste. That is equivalent to Chandigarh city every 9 years. So we need a large space to handle it, to store it, to dispose it. That is a wealth, but that is same time it is a very big problem to all the governments, all the municipalities, all the cities, all the individual even. If we see further that what type waste is there, then there is biodegradable waste is there. That is around 47%. Paper is around 8%, rubber is 9%, metal 1%, glass 1%, and rags 5%, other is 4%, and inert material that is generated generally from the construction of and demolition processes. So that is around 25%. So this is the general composition of the waste generated in our country. Here we can see the overall, if we by weight we can classify it. Then inert material, that is building material, demolition or construction material, that counts around 40%. Organic biodegradable waste, that is around 42%. So this is of much more importance for this agriculture purpose. Other 8%, plastic 4%, paper 6%. But there is very big problem that we are not aware about the outcome of this segregation, and we are not following any segregation from individual level to at the end user end level, we can say at dumping level. So inert include construction demolition waste, street sweeping, silt from drains, and other textile, leather and metal, glass, other material is there. And if we see the potential of how we can convert it to wealth, then waste to
I think there is some problem.
I think wires is to come.
I think connectivity is problem.
Is being recorded.
Then the problem with this urban waste is
Shiva, you share your screen again.
It is not sharing. Okay.
Actually, it was disconnected from your side.
Okay. Now it's okay.
No, it is seen as started screen sharing. Please share.
Okay. So if we see the again this urban waste, if we classify it, then there is again many problems with this urban waste. We can say there are many challenges. First challenge is at the level of collection and segregation.
Reshare, sir.
Reshare again, it is not visible. Oh,
Yes.
Not very.
what is the problem? Now,
No.
no.
Sir,
Yes.
Yeah.
Now,
Hello.
now it is okay.
It's
It is okay.
slow. Something is happening. So there are many challenges in waste collection and segregation. Municipal solid waste
Again, you are
needs mental. Then awareness at a house or waste generator level. Again, it has gone. Hello, Dr. Patel.
no, no.
Hello.
It is okay, visible, but your voice is
Is visible?
missing sometimes.
Okay.
It is okay.
Okay. Okay. Now.
Continue, sir.
Okay. So, collection and segregation process at household level, that is very much important. So, whether it is organic waste or it is paper waste or plastic waste or mixed or glass or metal or e-waste or sanitary waste, whatever waste is there, we have to segregate at the household level. And this is the biggest problem. There are many awareness programs, many training programs, even government put many other punishment program also legal that people should adopt this segregation process. But most of the people, even 90% people, they are not following this segregation at the source. Because if you are not segregating at the source, it means there is again you are multiplying the problem. You can see household waste, there are different kind of waste and there is provision in different municipality in different countries. They are dealing it with different type of approaches. If you go to any developed nation, then you will find there are in front of your apartment, in front of the house, you will find 3-4 types of bins, and they are putting it very following very what you call, it is a ritual. You can say they are following it just like a worship, and they are not throwing any garbage here and there. But here our society is suppose a very good, well-off people and very well-educated people. You can see sometimes they are just down their glass screen window from the car. You can see garbage bag is out on the road. So such type mentality is there. That's why this process is very much problematic. But if some entrepreneur want, because there are many new ideas, new innovations are coming, that how to get this segregated waste from the particular household. So they are putting many tags. They are also putting QR code to each and every household. They are putting QR code on the even dustbin. So this way they are selecting. There are many companies, many startups. They are coming in this way and they are doing this job. So why this? The each and every process, either you collect wet waste, or you collect dry or recyclable waste, or you collect hazardous waste or domestic healthcare waste, all type waste, they are having, finally they are having some money making activities or money making potential. So if you take it with full innovation, then everywhere money is there. Bulk generator are also there in different municipalities or cities. Like there are many mandi, sabzi mandi, their APMCs are there. So they are also leaving day to day lot of material, lot of green waste. That is very much useful for recycling to for plant nutrient purpose or for composting purpose. large kitchens are also there, like hotels, hostels, and different big where gatherings are there. Slaughterhouses are also there, so we can use that also. Now similarly, this garden, lawns, and different type landscaping, we are also producing a lot of green waste, and that can be again processed for income generating activities. Wet waste, if we further classify, then among wet waste, whatever we are generating in our homes, that vegetable, fruit peels, tea leaves, egg shell, leftover, so many type material that can be separated from the whole lot, and that can be sent for only the either for biogas generation or for compost making or for both. So such type starts up, they are interested with the green waste only. Then some rejects, they are saying red bucket. In our Indian standard, we are putting red bucket, green bucket, blue or different type buckets we are putting in the near the household. So those different type sanitary waste and recyclable dry waste, different type box, cardboard, etc. They can be recycled for different purposes, and that is another type of technology available, and that technology can be used to further generate the income from such type waste also. Then there are again electronic waste nowadays. That is a huge amount of electronic waste we are generating nowadays from each and every household. There are a lot of mobile phones, other electronic items, TV, then what you call computer accessories. So all we are generating a lot of things. From that also, there are many small units, they are working to segregate the waste material from that, and many factories unscientifically even they are just melting the material and they are getting out different type of metal from that. So such type things can also be organized properly and with full technology that can be extracted by scientific way. Recyclable waste also, it is earlier there was a problem that people were not using. There was no processing facility in our country for this PET bottles and other ones, because we are generating a lot of PET bottles, and those were even our kabadi wala that was refusing to purchase that. Nowadays, Reliance and other big corporates, they are working on it, and they are making rayon fibers from this PET bottles. So that's why nowadays that is also having values. So we need not to throw those bottles here and there. Similarly, different packing material from day-to-day use, we can also collect that and segregate them. Then for segregation, there is also a big business when we are selecting our dust bins. There are big businesses there that people are having different type of bins they are selling, and with 2 chamber, with 3 chamber, with automatic automatic pouring facility, automatic lid facility. So there are different innovations in this also, dustbins also there, and many companies are working on it, and they are in market already, their products are in market. So that is also a big business for new startups related to this waste management. Also, there are home composters are also there. At home level, you can take those bin type composters you purchase, and individual composting units you can convert your waste into compost, and you can use it in your kitchen garden or your flower pots. Then generally what we are doing, this plastic polythene bags, we are nowadays it is a lot of government is trying to stop that. So that polythene lining we are using in the dustbins. So that lining, if we can only we can have some alternate for this, then we can save around this much plastic bags per year. So we can think of this also, that how can we reduce such type waste at our household level. Then hazardous e-waste, this is really hazardous, but from this hazards we can also extract a lot of good material. So many what do you call, startups, they are also working on this material. A lot of precious material inside this hazardous waste also there. This market based, I told you earlier also, this mandis and other, they are generating this type material, and we can convert in the good quality compost, and that is nutrient rich compost, that is enriched compost, not like similar compost from the because these fruits and other vegetables, they are comparatively they are having more nutrients as compared to straw of any vegetative part of the any plant. So there are different type of composting units at to dispose urban waste, urban green waste. So there are different centralized facility also there, big plants are there, and also there are decentralized facilities also. There are different models for decentralized level disposal of this urban waste, and also there are centralized facility. If you can see the many corporates there in Pune, in Indore, in Bangalore, they are working for centralized facility of this composting. But a small startup in Gurgaon, Noida, and different places, they are working for just for one RWA, one colony, one apartment, like that. They are having a small composting units, and they are generating compost. They are selling it. They are converting it and selling it. They are earning a lot of money. Similarly, you can say this home composting units and household biogas units also nowadays. Many startups, they are working in this area. How to a group housing facilities, then how to provide container to them, how to prepare compost in those containers. So that area is also very much lucrative, and lot of money generating activities you can do when we adopt this. But also home gas collection, also biogas collection units, also few companies they are preparing, and they can collect the gas, they can use it, fill it and use it. Of course, it is not pressurized, but they have some technology that they can use it, and even for cooking and other purpose also. So this is the fate of urban waste. Now we can move to the rural waste, how it generates and what is the fate of it, how we people are utilizing it, and what is the general practice. So if we enter in the any village from north to south or east to west, whole country is having this scenario. You can see both sides of road you will find such type heaps, where each and everything will be, you will find in the either cow dung, you may find a tire also, you may find some shoes also, some bottles, some polythene. So everything is there. There is a big mess, and that is a very big nuisance at our level. Because we are very much ignorant about it. When there is rain, lot of nutrients leaching down from these heaps or from pit where they are putting this material, and that is not only uh, losing the aesthetic value of that village or that roadside, but also those nutrients, they are going to the different water resources, either to groundwater or surface water. So they are polluting everything. Similarly, this heap they are using after 1 year, they are just removing upper layer, they are putting there the whole thing in cart or in tractor trolley, they are putting in the field as a manure. So that manure is consisting lot of undesired things like polythene, other things, they are reaching to the field, and again, and also the nutrient, and you will see that material is not having very much good nutrient quality of that compost. So by this way, we are losing lot of nutrients in our rural area. And if we see how much nutrients we are losing through burning also, because burning is also a very common practice. I'm sorry. So there are different type of residue, different type of waste of in rural area. That is the rice husk and charcoal. That ash is used for rice husk and ash charcoal, additive for cement mix, glass manufacturing, active carbon. So that is also a waste material. Rice husk electricity generation. They are making the briquette for this fuel briquette for from this rice husk, and then again this rice husk can be used as a nutrient source for the plants also. Then banana peel and sugar fiber they can use for paper making pulp. Oil, empty fruits and bunch, that is mulching and organic fertilizer. Oil palm stem, rubber wood, softwood furnitures, onion skin, husk, bagasse. So all the material whatever we are producing, we are thinking that is waste, but that can be used for different income generation activities. You can see the lot of residue we are burning, and you can see paddy and wheat residue is we are burning around 40% paddy residue and wheat residue 22% the wheat residue. We are burning in few patches like in MP, Harda, and near this Indore region. You will find that they are burning wheat residue also. So in UP or in other states, many places you will find this is very costly material. Wheat extra you can find as equal to as costly as the wheat grain. It is around 15 to 18 rupees per kg. There was a rate sometimes during winters. So that type costly material we are burning, and that can be used for animal feed. Then here you can see 3% maize, 3% jute, cotton, sugar cane. So these things we are burning, and by burning we are losing many nutrients, and you can see there is how much loss due to this per year. You can see how much nitrogen loss due to this rice, phosphorus, potassium, it is 1.43 million ton. Nutrients we are losing per year only due to this burning of fuel. Similarly, you see the potential of this animal waste in reference to especially dung, not other things. So if we can see dung this much in these states and they are producing this much dung. So that means
It's not audible, sir. Dr. Shiva, I think again some problem in connectivity.
You are getting a screen, sir.
Screen is getting. We are getting a screen. The screen is visible. I want to contact. I'm contacting. Hello. Hello. Any connectivity problem, sir? आपका स्क्रीन बिल्कुल मूव नहीं कर रहा है. स्क्रीन मतलब स्क्रीन भी आपका भी फिगर जो दिख रहा है वो स्टिल है. ठीक है सर, प्लीज ट्राई अगेन. Please bear with us. He is trying. There is some connectivity problem at Delhi. Okay. But you are still, your figure is not moving.
Now screen and voice both are not getting.
Yes, I think he will connect again. There may be some thunderstorm or raining at Delhi.
Dr. Pathak, he is connected now.
Okay, he is connected now.
Maybe trying to.
Shiva Dhar, unmute
Shit.
yourself. Okay.
Hello.
Yes. Okay.
Let me see.
We are listening.
Now is it visible? The screen is visible or not?
It is being shared.
Okay, okay.
Yes, now visible.
Okay, okay. So I was discussing about the how much cow dung potential is there, how much dung is there. So that is around 133.57 million ton per year we are generating by these all the animals jointly. So they are having the, if we see the potential for NPK from different organic waste in India, that is potential you can say from nitrogen, phosphorus, potassium. So I am just giving the total of this. So around 5 million. Is it visible now or not? Again, some problem.
Visible,
Hello.
sir.
Okay, okay. So you can see overall, if we see the contribution from all type residue or waste, we can see 5.1 million ton from this uh, cattle, buffalo 1.5 million ton, 0.29 million ton from goat, sheep, from pig 0.1, from poultry 0.05, and other livestock from 0.16. Then from crop waste, that is 18.6 million tons. So that much nutrient we can uh, see there is potential. If we can utilize all the waste properly, then we can save this much nutrient applied through the fertilizer. So that is a huge amount, and if scientifically we can do, then we can have lot of potential for money saving or money making potential. So these are the resources either from urban area or from the rural area, and how to dispose it, what are the alternate to dispose such type material. There are some technologies, and especially there are many, we can say, opportunities. So waste management landscape in this slide, I'm showing that this municipal solid waste, how we can manage it. So one is biodegradable, other is combustible, CD waste, construction and demolition waste, inert material. So here this green one, all we can use for this composting, biomethanation, biofertilizer, anaerobic digestion, biogas, and even thermal energy we can produce from this. Then this combustible is directly we can generate the energy, thermal process, gasification, incineration, pyrolysis, or steam turbine or electric generator or power generation we can use it. Then construction demolition waste and inert material that can be used for land filling and biomining. So here this material can be reused for making buildings and other things, building material. So such type technology available, such type small scale industries also coming up very fast, and many brick making by this, they are again making from refuse, they are again making bricks and other road making material, they are also preparing from this. And also there are many alternate technologies to use this waste for other for some money generating activities. Similarly, you can see at a small scale, such type, some NGOs, they are working on that, they are using this waste plastic and other things, they are making very nice product from this poly product. And many corporate, they are also giving their CSR funds to develop different NGOs, they are financing NGOs are also working on this waste waste utilization facility. They are providing training to villagers as well as also unemployed youth to make different type of articles from this waste. And also this plastic, there are also some technology developed by this road for road making. This road is made from the plastics. You can see this plastic can be utilized for the road, but there are again some secondary or tertiary problems because there is also a danger of this microplastic pollution in sea water or water bodies. That is also very much common nowadays and it is visible. So there are many problems. You solve one problem, there may be other problems, then but we have to solve all those problems. Then there are many options also. Waste to energy, there is a lot of potential. You can generate waste to energy, waste to compost. I am already done. So many companies and many corporate sector, they are also coming like ITC and this Reliance. They are also coming in this composting making process. Excel Agro Industries in Mumbai, in Pune, there are big composting plants are there. They are making good quality compost and distributing to the farmers from this urban waste. Then recycled, as I told you, recycled construction and demolition waste. That is also again concrete aggregates they are making, and Bureau of Indian Standards is passing them. That CPW and other agencies using for this. Even individuals are using for material produced from this CD waste. Then there is another very big business, procurement and business related to equipment. Those are handling different type of waste. So that is also a big business. And one is ITCs running a program that is known as WOW, well-being out of waste. From waste, they are making different type of product. And similarly, they are at big, you can say very big investment they did from Madurai, Coimbatore, Chennai, Tirupati, and all cities and towns they have covered, and they have covered many more than 5 lakh, 3 lakhs, or 50,000 according to the size of city. They are much households, and they were collecting, segregating all the things they are doing, and they are preparing very valuable product from that waste. Then education about this waste, whatever waste is there. So how to convert, not only about the plastics, we have to educate about all type of waste. So such type training and awareness programs are required very much. So how to utilize these waste like plastic, metal or anything. So small training programs are very much needed to the concerned stakeholders like rag pickers and other kabadiwala and other things, they are working on it. So many NGOs are also involved in this. Is it visible again? There is some problem. Hello, Dr. Pathak.
Visible, it is visible, quite
It is
visible.
visible.
Okay. So other options are or uses, alternate uses of this residues are there. We all know that IGFRI is also already working on the cattle feed from different type of residue, and from that residue, when cattle feed is ready, even then there is a lot of residues left that is not useful for making the feed. That can be utilized for composting. Energy from crop residue, ethanol from crop residue, biomethanation, gasification of residue, fast parallel biochar making. And composting is most important. We can say that is most eco-friendly product what we can make from the crop residue, and from different type of residue which is sometimes difficult to dispose, like rice residue. This composting may be very much useful or beneficial. So this residue can be used for different type of ecosystem services like biofuel, animal feed, industrial raw material, soil quality improvement, and biofuel. Traditional and modern liquid biofuels we can prepare. Animal feed, we know. Industrial raw material, we know. Different furnaces are nowadays using this mustard residue. Suppose mustard stover is utilizing by different furnaces for after making the fuel bricks. And also this, I told you, this rice husk residue, that bricks also they're making fuel blocks, and those blocks are, they are getting good price, and farmers are getting good money out of this residue. Then soil quality improvement by using this compost, so agronomic and biomass productivity, sustainability, erosion control, and all these benefits we can get by using such type material. Then different composting technologies at different scale are also available nowadays, and they can be adopted as per the scale of the production. So composting, everybody know that it is a rotting and natural process. You leave anything anywhere, it will rot naturally. But scientifically, we can enhance the process. That is the different technology, how to enhance the process, how to fasten the process, and how to get good quality compost. That is the technology. So there are different methods. There are traditional methods, aerobic composting and anaerobic composting. So there are many methods. We have gone through that Bangalore method, Indore method, and other methods, pit method, heap method. But the people didn't adopt, farmers didn't adopt any methods. We have gone through all those methods. But when we go to enter in the village, we will find that heap only. So because people are not aware about it, and people don't know how to use it, and people don't want to handle this such type product, that's why there is problem. Because whatever we have given them, that was very much complicated. If you are saying in Bangalore method and Indore method that you make one layer of cow dung, one layer of this garbage, one layer of again cow dung. So one time it should be a one-time process. If garbage, we want to get rid of the garbage, so you don't want to handle again and again. So such type techniques are required, so that one-time solution should be there. So only that can be done by large-scale composting, this bend row, or aerobic composting may be the maybe a good direction for handling such type product. So rapid composting, there are different rapid composting methods: shredding, Berkeley rapid, mineral nitrogen activated, Dakota method, and many methods are there. And this aerobic composting and aerobic composting, we can classify all the composting methods within two broad groups. So aerobic composting is, that is, oxygen is required. We don't need pit, we need heap only. So above ground we can make any structure, so that if we can aerate the pile, and we can get the proper compost. And this aerobic composting is, earlier we were doing, but here lot of order and smell problem was there. It was taking lot of time, and also the methane generation is there. So people nowadays adopting this aerobic composting. Here only CO2 and ammonia is coming out, and due to heat and different type of microbes, we are decomposing the material. And this method, I have given some detail of these methods, but I am not going inside this because, but you can understand that these methods were very much complicated. That's why people didn't adopt it, and they are just they are still in the books only. So this Bangalore method also, native method somewhat working, and government is pushing in big way that you prepare this native compost by using making some structures, and those structures required to spend some money, but people are not very much interested to spend the money to make some concrete or structure from the bricks. So don't want to waste money on this waste to make the compost. Large scale composting is very good for institutional composting when we are generating a bulk of this waste, bulk amount of waste. So this composting method is very much beneficial for small cities, small towns, mandis, different institutions, universities, so like that, different RWAs. So it is very much useful, and it doesn't require very high amount of investment, and but it needs space. So wherever space is a problem in very big cities, it is again a problem. But wherever space is available, then this method is very fast, cheap, and very uh, nice method, we can say. Here we are making in large scale composting, we are making windrows. We are turning it at different intervals depending on the different type of substrate. In IRI, we are using the same technology for making compost at large scale. In this process, this process is also used by many corporates in Pune, in Indore, or in Bangalore also. So they are also using the windrow method to decompose the material, and after that they are sieving it. So that process involved, compost pile is there, we are turning, mixing, so water and heat and CO2 is coming out, and final product is ready, and using organic matter, minerals, water, and microorganisms. So this is raw material. Oxygen is circulated inside the heap, and that will fasten the process. So there are different stages of this composting. Mesophilic stage 10 to 40 degree, then more than 40 degree. It goes up to 55 to even I have observed this is 75, more than 75 degree temperature of heat you can get when you are turning it at proper stage. And by this way, we are killing all the weed seeds, all the pathogens inside the heap, and we are making very good quality compost. So this is again somewhat more process of different how this temperature goes on, how it is going down, how this stabilization process get, how this thermophiles, mesophiles, different type bacteria population behaving in this, how CR ratio is going down. So this is all about the composting process and how organisms are working. So different organisms nowadays, they have been all isolated, and they are available in the markets. Different institutions have isolated these organisms and made them a consortia. So whole things they are mixing together, they are selling it, and this NCOF has prepared a waste decomposer that was having a lot of publicity. IRI also having prepared a composting consortium. So different type consortium are there. We have also prepared a consortium for rice extra decomposition in the in situ. So there are different type consortium we are working on. So these are different type of microorganisms. Then these are the different ideal conditions for composting. CN ratio is very much important because we are converting from higher CN ratios to lower CN ratio up to 25 to 30 on dry wet basis. Then we are also preparing different type of enriched compost. They can be prepared, and the enriching of, because composting is now become very common, and many stakeholders, many companies, many startups, they came in this field. But nowadays there is competition that how much good quality you can prepare. So there is a lot of enrichment through rock phosphate, iron pyrite, or maybe from microbial consortium, different type of microbes, mycorrhiza, or whatever you can add in that, and that should be visible, or that should be functional. So that type compost people are nowadays selling, and that is very big market for such type product is available. Home composting, I told you that different type of structures are available nowadays. In those structures without smell, you can prepare good quality compost. That is also for different colonies, different type innovations are there. This is OWC 300. It is decentralized waste composting, and it is converting 5 kg per hour to 5 ton per hour. Their capacity machines are available, and they're running on the electricity, but they are not successful. Some compost, after this we have to take out the material in the composter, and again we have to wait for 10-15 days. So there are many disadvantages, because I told you I'm not going in much detail, because a lot of vermicomposting is also a very good venture, and many rural youths, those are unemployed, they can adopt this process. By this way they can earn a lot of money. And the very good quality compost we are getting by the this vermicomposting, and we can use cow dung as well as 20% other material. Mixing with that, we can prepare good. And there are different models at a small scale or large scale. You can prepare this. So composting potential of our country is 54 lakh tons, metric tons, and current composting units installed for 56 plant installed in our country. That is 10 lakh metric ton capacity, and that is 1.5 lakh metric ton is producing. And under construction, there are many plants are under construction. So you can see different cities, how much target, how much production capacity, different plants are there. You see all India, they are working on this, making different type composting plants. This is slide provided by, I think you people might know this, Eco-Friendly Solutions. Earlier he was also working on multi-purpose to multi direction, we can say. He is also expert in compost, and he is also expert in making this vacuum packing of wasted fruits. Mr. Badhavan, I think Dr. Pathak, you might know him. So he is also an entrepreneur. He's having his stake in all type of products. So IRI composting model is slightly based on the, I told you, just I explained, this is the type material is generated in the IRI. This is crop residue, and then such type machines we are having to process this material. We are making windrows, and even this is small twigs and other things. We are again making the compost from this. We are just these twigs we are making chips like this. So simply we are making chips. We are having this shredder we are using for this some hardy material, hardy this crop residue also sometimes, like this maize, and sometimes pigeon pea residue, like cotton sticks. So we are making compost for all type biodegradable material. And this is windrow method. We are first making windrow using cow dung and different type of crop residues. Then we are using a loader fitted on the tractor, and so cost is around 2.5 lakhs. And we are handling lot of because bulk material we need to have such type equipments. So this loader is making windrows and also loading unloading trolleys. It is very good. Then we are using one turning machine. Those windrows we are turning by this machine. This is made by this IRI, our engineering department. And so we are using this machine for turning and mixing of such type heaps. And this you can see. So this type heap is, they are changing color, they are changing its texture. So this is working condition. You can see in field how we are making compost. So this is windrows of different compost. So 3-4 turnings are required to for this these windrows, and you can see how fine quality compost we are getting after processing by this way. You see, raw material is here, and this is final product is there. And we are also this campus waste. We are also getting some polythene, other things, leaves are there. So we are sieving. We are having a big sieving plant. We are sieving this garden waste from lawn, from haze, from campus area, tree leaves. So that we are sieving by this machine, and we are also generating around 10,000 tons compost from here itself. So so this is the whole process, making windrows, turning, and then final product is ready. So in same way, we are also having vermicomposting technology that is not like other. If you go to the YouTube or you go to any government scheme, you will find you make the pakka trench and then put worms there, and they will die after some time. So only that process will end after getting training and after getting subsidy. So this vermicomposting is very much successful in loose brick system. We have developed this loose brick system here. And in this loose brick system, there's facility that you can, this windrow you can replace by fresh material. And also there is a lot of money people are wasting on this type of structure. And also this poly structure for this vermicomposting. So these structure are also not very successful. Successful is this brick structure or open in the field without giving any support. So these structures you can see here. These structures are earlier recommended by different agencies, but still they are also they are not working well, because this cement, after release of organic acid, cement is falling down. So just quality of the compost is deteriorated, and also due to less aeration, the vermicomposting process is slow in such type of structures. So this structure is not preferable now. And you can also use this vermicomposting at your kitchen garden or broken vessels. You can use any type of vessel. You can make the vermicompost. And this loose brick system, you can prepare a field like this, and you can just 2 bricks, you can use 2 layer, and then you can make a windrow here. Then if you don't have bricks, then even you can use crop residue to make the compost, and that is also very low cost method of composting. And if you don't have even crop residue, then you can, if you don't have crop residue, then you can go through only simply on the ground. You can make such type windrow, and you can prepare compost without any problem. So at household level, you can also your broken flower pots, wash basin, that can also be used for making the vermicomposting. So many Delhi people, they are making at their homes lot of vermicompost they are preparing for their kitchen garden. So such type in kitchen garden, you can make such type of small structures, and you can make vermicompost at your place. So the vermicomposting, actually the biggest problem with this vermicomposting is to separate worms from the prepared material. So what we are doing, we are just removing this bricks and placing to a new place and making the more wide this windrow, and the prepared material we are making in half place. So with this, there are a lot of worms are there, and we are putting fresh material near to that. So after 10 to 15 days, whole worms, they are migrated to this fresh one, and we can collect this without investing a single penny on the labor to separate earthworms from the material. So this technology we have developed. Then economics, we can see this is very cheapest price. Lot of many starts, what you call many MBA graduates, they are coming, they are starting in nearby Delhi area. So many have they are preparing this vermicomposting using this technology. And nowadays there is lot of, due to natural farming, government promoting this natural farming. So preparation of Jivamrit and different type Amrit we are preparing, and we are utilizing nowadays in for our experimental purpose, not for the sale. But in future, I think we will be able to prepare some formulations of such type to sell it in the open market. So this is we are selling also this prepared compost, and we are earning around 10 to 15 lakhs rupees by sale to kitchen gardeners or others. They are coming to our unit, and also we are preparing in a year around 5,000 tons of compost per year. So uh, that cost is around 2 crores. But that is, we are generating from handling of 30,000 tons of raw material from generated from the campus and farm. So that is, and simply we are using 17 to 20 lakhs to run this unit per annum, and we are preparing around more than 2 crores. So that's why you can see this is a uh, very profitable business, very lucrative business. That's why many corporates they are coming in this business, and they have started many things nowadays. So you can see this much quality compost we are making and we are distributing. You can see how many how much quantum of this that compost we are preparing, we are giving to our farm for different experimental area, for orchard, for household areas. Earlier we were purchasing around 1.5 crores we were spending on this, and we were not getting that much amount. Nowadays we are providing 3 times of that amount, and we are saving that money. So that model is very much successful, and that model can be used for all the institutions and universities to prepare such type compost model. So these are the future aspects that you can prepare. Many entrepreneurs can come to this area. They can develop small or different scale. They can work, and they can do good for environment. They can do good for nutrient saving, or they can use. They can give contribute towards the organic farming also, because organic farming needs a lot of compost. So thank you for your kind attention. I just want to say all our dreams can come true if we have the courage to pursue them. The Walt Disney has told this thing. Okay, thank you. Thank you very much.
Thank you, Dr. Shiva Dhar.
Yeah.
I invite any question from the participants if there. Dr. Raghavendra Singh. Dr. Raghavendra Singh is there. Dr. Raghavendra Singh is
audible. I am audible, Dr. Patel.
Yes, your question, sir.
Just my first thanks very much to you and Dr. Shiva Dhar sir. A very nice and very informative lecture. My small concern is this: the microplastic in treated water is remains. This is nowadays also very big issue. Is there any such remedy is there, or is anything commercially viable? Something is available so we can remove this because this is very small micron of plastic, less than 5 microns. They remain in the water, treated water, and that is actually have many implication in livestock. Sometimes they are using some other water for this purpose. So sir, this is my small concern. So I'd like to hear the right platform to
Yes, sir. Actually, your concern is really, I'm also concerned with it. This area is very vast area actually. Waste is not a one type of things commodity you can handle. This is 1,000 types of material and 1,000 type technologies are working. So one may not be expert for all. I become the expert for compost only, but other material handled by the IITians, they are working on it, and our others are working. Road building institute is there, that is working on it, that how to check this microplastic. But my only contribution to reduce this microplastic is this, that I can emphasize only to just segregate material at source. If you segregate material at source, then there are many technologies where you can utilize this plastic without leaving this residue microplastic. I think that may be the best solution.
Okay, sir. Thank you, sir.
Any other questions, sir, from participants?
Yeah,
Dr. Sahai?
thank you so much, Dr. Shiva Dhar Misra, sir. Your talk was very informative and we could come to know what is happening in IARI also. From 1st July, I think government has banned many single-use plastics.
Yeah.
I think 17 items are there in that list. But
Yeah.
it was astonishing to see that plastic bottles are not there. Means I was guessing what could be the reason they have not banned plastic bottles. But I think in plastic category, that is most biggest factor to contribute to this type of pollution.
Yeah.
So what could be your
Yeah.
ideas on this?
Actually, as I told you in this my presentation also, earlier even this plastic was unattended by any stakeholder, even your kabadi. He was refusing that I will not take this bottle because this is plastic bottle. This is of no use. Cold drink, water bottle, Bisleri bottles, other bottles, they were not purchasing. But now you will provide them, then they can give you some money for that. So reason is that few corporates like Reliance and other, they have started very big plant. Reliance has started very big plant. I forget the city where they started, but that has very big capacity. So they are making the rayon cloths, raincoats, like that. It's a type fiber they are making, and they are making different clothes by that. So that is now recyclable, that is utilizable. Again, they are taking those clothes back, and then again they are making different type of product. So they are reusing it. So that's why I think there is no problem, and that's why they are not stopping these bottles.
But collection of these scattered plastic bottles, that is a big task.
Yeah.
And
That only awareness,
and
only
that-
awareness in the people.
and that cannot be done on, even to 50% also if it
Yeah.
goes in a moment.
Yeah, of course.
Question? Or if not, I invite Dr. Arvi Kumar.
I think Dr. Rajput sir wants to say something.
Dr. Rajput, if you want something. Sir, unmute
Sir,
yourself.
kindly unmute.
Unmute yourself.
I want to congratulate Dr. Shiva Dhar for his very nice presentation. I feel very happy to attend his lecture, his talk, and he gave very useful informations. And I am interested in this composting process. And he also told that he is an expert in composting. So if he can provide more details, managing composting at household level, that will be very useful, because technique is important, process is important, equipment is important, and if those details are available, people can make use of this even in cities, also in villages, at individual house level, as well as at farmers level, as well as at village level, as well as at watershed level. So I think your presentation was very useful and I liked it. So I must congratulate for your presentation. Thank you very much.
Thank you, sir.
Thank you, Dr. Rajput.
We are providing training on composting and vermicomposting to all type of stakeholders, not household, starting from household ladies, kitchen gardeners, from villagers, from NGO people are coming, and from ministry also. Even scientists are coming from different universities. I am providing training to them also.
Very nice.
Okay, sir. Thank you, Dr. Shiva Dhar. Dr. Arvi Kumar, for brief comment, sir. Dr. Arvi. Dr. Sunil Tiwari is there.
Yes, Dr. Pathak.
Yes,
I am here, I am listening, and it was very informative and very knowledgeable topic Dr. Shiva Dhar has shared. And he has also narrated the success story. So one can see how how the scenario changed. Say, for example, of IRI, where a lot of money was devoted for procurement of those farmer manure or compost, but now they are in surplus and providing that compost to other stakeholders and also maintaining their campus very well. So congratulations to Dr. Shiva Dhar. My question is very basic but very important. You might have been interacting with the stakeholders. What are the constants in promotion of these technologies? See, in cities, urban waste is nowadays managed, and a lot of awareness there. Government policies and local governments are taking there, because there is a concept of smart cities. But if say the small towns and even small district level headquarters, and you have already shared the examples of villages where heaps of garbages are there. So what are it's only the cumbersome techniques or something else, constants?
Actually, of course, it's a cumbersome job, because waste, when they are looking, it depends on the individual to individual and attitude of the people. I got one project from Delhi University, and about 50 students from Delhi University, they were involved in that project. And I have given this job to those students. I made 3 teams. One team, you just train to the people that how to segregate this material. So one I have sent to New Friends Colony, where very posh persons, very high class persons are residing, good officers. So 2-3 colonies, those are having class 1 officers and other businessmen. One colony we have selected, RK Puram, where middle class people are there. One colony we have selected, this just slums, JJ colony. So 3 colonies, 3 teams were working. They have given training, they have given dustbins, everything. So this JJ colony, 90% people adopted the techniques, they did it properly. But those were middle class, so 50-50 response was there. And higher class society, post colonies, they didn't follow even a single person, they didn't follow any norm. So this is our attitude. This is our attitude, and which is working, and that is creating problem to others also. Even we scientists at our level, you can think, at your home, you are having one dustbin. Even you know that we have to segregate the things. And that polythene is coming, that is also going in there. Then garbage, vegetable, everything you are putting there. So you think from yourself, then you can point out to others. So this is my, I am giving this lesson to each and everyone, that if you think yourself, only then you can solve the problem.
Yeah, this is our attitude, sir. Dr.
Yeah. Thank you very much.
Okay, Dr. Vijay Yadav is there. Dr. Vijay.
Right, sir. I'm here only.
Sir. For any comments, sir?
Thank you, sir. And first of all, we are really thankful to Dr. Shiva Dhar Mishra, sir, for giving this very informative lecture. Lecture was not only useful in terms of the institutions like IRI, where we have a lesson to learn, but he had narrated for everyone in his whole of the talk. There have been everyone to take away home message. So thank you, sir. And I really enjoyed, and there have been many points which we have learned from your lecture. So thank you, sir. This is only from my side.
Sir, Dr. Mishra, one of my suggestions is we can include robotics in this type of entrepreneurship.
I'm using already.
Okay, then it is great.
I'm using robotics, but that is very costly, and maintenance is very because we don't have the trained persons to do that. So some persons from computer engineering, 2 students, they are coming and they are working on it.
Actually, my opinion was why these 2 lectures was taken, because how imaging can be utilized for segregation of this. That can also be possible.
In IIT, we are having one project in collaboration with IIT, where we are also working with that. No?
Dr. Ekera is there, sir. Dr. Shahid Ahmed. Okay, sir. With these remarks, now I am closing. If no question is there, I invite Dr. Deepak Upadhyay for formal vote of thanks. Deepak Upadhyay is there?
Yes, sir. He is there.
Okay.
Yes.
He is listening or not?
Yes, sir. Yes, sir.
Okay, please, for formal vote of thanks, I am inviting you.
Thank you, sir. Thank you so much. And on behalf of the organizing team, I want to first of all extend my heartily thanks to the today's invited speakers, Dr. Puneet Mishra and Dr. Shiva Dhar sir, for joining us and for presenting their thoughts, their research activities, and for sharing a lot of knowledge with the participants. On behalf of whole IGFRI, I want to thank you, sir. Thank you so much. And I want to thank the Director IGFRI, all the organizing team, all the office bearer of the ISAE and Range Management Society of India, all the head of divisions, PCFC, and all the scientists and attendee to attend this lecture. Thank you so much.
Okay, sir. With this vote of thanks, I am closing with a comment that for next 2 lectures in August, on August 20, I am planning from IPTMU section, ADG Dr. K. Srinivasan on this IPR issues, and second lecture will be agroforestry and timber products by Dr. Handa from KVKs, Jhansi. So with these remarks, thank you all for closing this session.
Thank you. Thank you very much.
Thank you.
Thank you, Dr. Sir. Thank you.
Very much.
Thank you so much, sir. Thank you very much.
Sir, close correct?
Close.
Okay, sir.